All right, let's go back a page and look at another example of writing an equation of a piecewise function. This one has a little bit different stuff in it. The last one we did with writing equations had 4 pieces. This one has 1, 2, and a third down here. And this third one's going to look a little bit funny to us, but I do want to point out what it is to write that one. So that first one there on the left is another line. It's got y equals mx plus b. And this is a good example of one where I would be able to tell the slope. So again, the bigger boxes are counting by 2's. So my slope on this one going from, let's say, this point to this open circle would be up 1 over 1, 2, 3. So my slope is 1/3. And you can either estimate where it's going to cross, or you can use your y minus y1. My estimate might not be so good, so I'm going to use y minus 0 equals 1/3 times x plus 4, because it's minus a negative. So this equation would be y equals 1/3 x plus 4/3 for this piecewise function. That second set, again, is going to be a horizontal line at y equals -1. And that third one, you should be able to recognize this right here as half a circle. So a circle, as we have seen it before, is y equals x, or x squared plus y squared equals r squared. So if I look at this, I'm going to see, if I wrote that circle, the center of this circle right here would be right there. So that would be x minus 6 squared plus y minus 1, y plus 1 squared equals, then this has a radius of 2, so 2 squared is 4, right? So we're going right 6 and down 1 for the center. And then usually we want to solve that for y. So first I move this entire thing to the other side by subtracting it. And I'll move down here to show this. Y plus 1 squared is equal to 4 minus x minus 6 squared. Square root both sides. That's going to give me y plus 1 is equal to the square root of 4 minus x minus 6 squared. And then we would subtract 1 from both sides. So that's going to be the half of my circle, or that's going to be half of a circle because I square rooted it. If I want the bottom half, the one additional adjustment that I will make is a minus sign outside. So when I write my piecewise function again, it's going to be f of x is equal to, do our bracket here. The first equation is going to be 1/3 x plus 4/3. The second equation is going to be -1. And the third equation is going to be negative square root 4 minus x minus 6 squared minus 1. And then I have to put those restrictions on it. This blue piece at the beginning is defined for x is less than 1, because it's an open circle, or less than -1, excuse me. It's an open circle at -1 and to the left. That pink piece in the middle, I will make that between -1, and that has a closed dot, and we will do, let's see, 4. And I can choose to make the 4 closed here, or I can make it closed on the next one. And then the circle is defined between 4, and I'm going to make that not included since I included it in the other piece. And if that's 6, 7, 8. And I'm going to go ahead and include 8 since it's got a closed dot. Let's do on the next page then, going back to this page, let's see if we need to do another example. Here's a couple more examples of writing equations, and then one more of graphing, and we'll kind of finish up there. So this particular one, we're going to go ahead and write the graph for it. The first one here, question 2, shows a cubic with an absolute value. So this one only has 2 pieces to it. So this cubic centers right there at 1, -1, but it is backwards from what a cubic normally is. So I'm going to go ahead and say the cubic is right 1 and down 1, and then ask myself what makes that flip across the y-axis. Well, that's a negative out front there. The absolute value is centered right there, so that's my absolute value function moved right 5 and up 6. This one is flipped across the x-axis, so there's a negative out front. This one was also, the cubic was also flipped across the x-axis. You could have done that as a flip across the x or the y, but it's easier to show across the y. So our piecewise function is going to have 2 pieces to it. First, it's going to have the cubic. Then it's going to have the absolute value. And that cubic is defined for x is less than 2 because of it being an open dot at 2 and going to the left. And the absolute value is specifically between 2 with a closed dot and 9 with an open dot. So then 3 is similar to that. This leftmost one is a quadratic, and that has its vertex up at 5. So my quadratic I would write as x squared, no parentheses needed because it's not side to side at all, and then plus 9, but it is negative out front because it's flipped upside down. That second segment is an equation at y equals 3. And that third equation is an absolute value that is moved right 5 and not up and down at all, and it's actually kept normal so that you don't have to do a reflection. So I'm going to use actually this to make my piecewise function here. The quadratic is defined for x is less than 1 because it's an open dot at 1 and then to the left. That horizontal line is defined between 1 with a closed dot and 3 with an open dot. And that absolute value starts at 3 and goes out to infinity, which means I want to just say then x is greater than or equal to 3. Okay. And then one more graphing equation one. Let's take a look at that one at the bottom. This one I have a quadratic moved up 3 and flipped upside down. So I'm going to start out with a quadratic that looks like this. Okay. This one wants me to keep it for x is less than or equal to 2. So I'm going to go ahead and erase anything that is to the right of 2, which I actually only drew that. So it's going to start at 2 and go to the left with a closed dot. The next one is a line that starts at 4, up 4, and has a slope of 1/2. Kind of missing a line on that one. But this one wants only greater than 2. So I'm going to go ahead and erase the dots before 2 and make it an open dot at 2 going out to the right. Okay, so that would look like that. For your homework on this section, we're going to do quite a bit of this because it takes a little bit of practice. So I would like for you to start on this page right here, which is page 132. We're going to do 132 along with 133, all problems. We're going to do 134, 1 through 7. And we're going to do 135, 1 through, I think I stopped at 12. But you should have the rest of this class period. I am not intending this all to be homework. You should have a good chunk of the class time to work on this. And then once you submit, check your answers online.